So let's draw some Lewis dot structures for covalent molecules. So it would be molecules that only have covalent bonding on the inside of them. First thing that you're going to want to do is to draw out the element symbols for every element on the inside of your molecule and try and arrange them symmetrically. So for CH4, that's what this is going to look like. Carbon in the center and hydrogen around the outside. When in doubt, try to put those hydrogens around the outside. The next thing you're going to need to do is a quick little math problem, and it is S equals N minus A. What that represents is the number of shared electrons is always going to equal the electrons needed versus the amount that you have available. Needed is basically following the octet rule. In other words, every single element on the periodic table needs 8 electrons around the outside of it to be completely happy. And that's with very few exceptions. And I've listed them here for you on the screen. Most predominant would be the hydrogen, which only needs 2 electrons around the outside to be happy, but others include beryllium and boron, phosphorus and sulfur. Now the phosphorus and sulfur ones get a little confusing, and we'll address those later. So let's go ahead and count up the electrons needed for this atom to be completely happy. The carbon needs 8 total electrons to be happy. Each hydrogen needs 2 total electrons to be completely happy. So carbon's 8 plus 2 per hydrogen would be 8, 9, 10, 11, 12, 13, 14, 15, 16. Available is how many valence electrons the atoms actually have. Carbon actually has 4. Each hydrogen has 1. That would bring our total to 4, 5, 6, 7, 8. So our S equals N minus A is 16 minus 8. That gives us a total of shared electrons of 8. Now this is going to help us determine how many bonds that we need to draw in. In a bond, 2 electrons are shared. So if I know how many total electrons I'm sharing and divide that by 2, I should find out how many bonds I'm required to draw. In this case, that would be 4. So I'm going to go ahead and draw in my 4 bonds, and here they are. And then before I leave, I need to make sure that my whole structure is extremely, extremely happy. I need to make sure, first of all, that I've drawn in my 8 available electrons. So if I look at my structure, I count the electrons in each bond first, and I find out it's 2, 4, 6, 8. 8 electrons have been drawn in, so I've at least fulfilled that. The second thing you want to check is to make sure that each atom is touching the appropriate number of electrons. Each hydrogen needs to touch 2 electrons. If it's touching a bond, it's touching 2 electrons. In this case, each hydrogen is touching 1 bond. They're all very happy. The carbon needs to touch 8 total electrons to fulfill the octet rule. Carbon is touching 4 bonds. That's 8 total electrons. So carbon is completely happy. And this completes the structure of methane. Let's try something a little bit harder. Let's try to draw NH3. Again, we need to arrange the element symbols for everything involved in this molecule symmetrically, which for this case would probably look a little something like this. I'm limiting myself to the 4 sides around nitrogen, so I can't get them all around there quite perfectly. Let's do our S equals N minus A. Need, the nitrogen needs 8, each hydrogen needs 2, so it would be 8, 9, 10, 11, 12, 13, 14. The A, available. The nitrogen has 5. The hydrogens each have 1. So it would be 5, 6, 7, 8. So our S equals N minus A is essentially 14 minus 8. That means that we're going to be sharing 6 electrons. If I divide that by 2, I should find out how many bonds that I need to draw in, and that would give me a total of 3. So I'm going to go ahead and connect all of my atoms with my 3 bonds, and that would essentially look like this. Then I'm going to start to check to make sure that everything is happy. did I actually draw in all of my 8 electrons? Well, so far I've only drawn in 3 bonds. Each bond has 2 electrons in it. I've only drawn in 6. I'm 2 electrons shy. So I need to draw in 2 dots somewhere on my image. So let's check to make sure that all of my atoms are happy first. Well, each hydrogen is touching 1 bond. Each bond is 2 electrons. Hydrogen needs to touch 2 electrons to be happy. Each hydrogen is happy. Nitrogen is touching 3 bonds. That's a total of 6 electrons. But he follows the octet rule, so he actually needs to touch 2 more electrons. So to fix this, I draw my extra 2 electrons that I still need to draw in on top of the nitrogen in the form of a lone pair. And that would complete my structure for ammonia.